We've got a really awesome speaker coming on. Her name is Kelly, and I have to ask, is anyone else here really excited about dark mode in iOS 13? Yeah? Have some of you guys already started using dark mode in the beta? Yeah? Because I've been waiting for this for years, and part of Kelly's talk includes a way you can adopt dark mode into your own projects. She also has two super cute cats named Murky and Nova, named after characters from Heroes of the Storm. Her favorite color is purple, and I feel like this is just the most appropriate thing. She's having a very lucky conference, but she still plays Pokémon GO, and yesterday she won a purple shiny. So I think that's super exciting and bodes really well for your talk, Kelly. This is Kelly, everybody, iOS engineer at Reddit. Please give her a really warm welcome.
All right, thank you so much for the intro. All right, I'm Kelly, as she mentioned, and I'm here today to talk to you about color. Who here likes color? Woo! So a little bit about myself before we start. I'm an iOS engineer at Reddit. I work on the moderators team, so I'm building out moderating tools in the iOS app. I also worked on the styling component of each subreddit, where moderators can set custom coloring, custom imagery in each subreddit. So bringing that to mobile was a huge haul, and I had the pleasure to work on it. And that's kind of what inspired this talk for you today. Now, to start off, I'm going to give you an overview of what I'm going to talk to you about today. So to start, we're going to talk about color spaces, as well as the components that make up a color. After that, we're going to talk about contrast and how it applies to accessibility. And once we all have a mutual understanding of each of these things, we'll move on and we'll talk about custom coloring and theming throughout your app. This includes adopting dark mode in iOS 13, which I'm particularly excited about. After that, we'll move on to a different topic of color customization when you allow users to actually set the coloring in your app. And finally, we'll walk through some code examples of how to handle color collisions client-side so that your app looks good and it's accessible. So to start, let's get a basic definition of what a color is. When defining color, you need to take into consideration three things: light, the object that you're looking at, and the human eye, which is then perceiving the color of the object you're looking at. Let's dive a little bit deeper into the first topic here of light. Light is the main source of color in an object. Objects then react to light by either reflecting the colors in the light or absorbing them. Objects that reflect all of the color in the light are perceived as completely white. Meanwhile, objects that absorb all of the color in the light are perceived as completely black. Let's look at an example of this. Here, we have the sun shining on an obviously green cat, because cats are green. And then we have the human eye, which is then looking at our cat. Now, you might be wondering, why is this cat green? Why do we see it as green? Well, the cat is absorbing all of the reds and the blues from the sunlight. Meanwhile, it reflects out the green color, which is what our eye then is able to perceive. Now that we have a basic definition of color and how light affects color, let's talk about how we describe and we measure color. We do this through what is known as a color space. And color spaces, also commonly referred to as color models, are ranges of colors represented as tuples of numbers. And inside these tuples is each component of the color. Now, you might be familiar with some common color spaces, such as RGB. But today, I want to focus on the Hsv color space. This stands for hue, saturation, and brightness. Let's look at the first component of the Hsv color space: hue. Hue is the attribute of a color by which it is most identifiable. It is represented as a scale, a degree, from 0 to 360, as seen on a common color wheel. Red is represented at 0 degrees. Green is at 120 degrees. Got ahead of myself. And blue is represented at 240 degrees. Now, let's look at the second component of this color space, saturation. Saturation is the measure of the intensity of the hue of a color by which it is most identifiable. It is represented as a percentage value from 0 to 100%, where 0 represents a shade of gray, and 100% represents that full hue of the color. Let's look at an example of this through an image of a cat. Here is a regular photo of a black cat. Now here's this same photo with the only change being that I've increased the saturation to 100%. You can see that the intensity of the hues are exploded fully. Now let's turn the saturation down to 0%. You'll notice that the vibrance of those colors has disappeared, and all you can see is the grays and the blacks. Now let's move on to the third component of the Hsv color space, brightness. Brightness describes the perceived intensity of the light source of an object. Now, this light source could be from the sun, it could be from a candle, or any light shining upon an object. It's also measured as a percentage, where 0% is a shade of black, and 100% represents that fully dazzling version of the color. Here's another example of brightness using the same image that we saw earlier. The top photo, you can think of the cat sitting outside, but the sun has gone down. And the bottom version, think of it as the sun is shining fully. Now, the cat's actual color has remained the same. The only thing that has changed is the intensity of that light shining upon the object. Therefore, you can think of brightness in terms of adjectives as dark, or dim, or bright, or dazzling. So now that we've explored all of the components of the Hsv color space, let's talk about why you might choose this color space over, say, RGB. Well, the Hsv color space is actually just a simple transformation of the RGB color space. And it was designed for human consumption so that you can more easily predict the color that will be output when you're just looking at each of the components, hue, saturation, or brightness. Now here on the left, we have an example of a color where the hue is at 120 degrees, and the saturation brightness are both at 50%. Now, if you remember from earlier on our color wheel, green is represented at 120 degrees. So I think most of you can probably guess that this is going to be a half bright, half saturated green. Exactly that one. Now, with the RGB color space, unless you've memorized all the combinations from 0 to 255 for each of the R, G, and B components, it's going to be pretty challenging to understand exactly what color is going to be output. Now, for those of you still sitting there trying to figure it out, I'll give you a hint. It's the same green. Now, let's move on to our next topic of contrast and how it applies to accessibility. Contrast can be defined as the difference in brightness between two colors. It's measured as a ratio from 1 to 21. A high contrast between two colors is very important when it comes to providing an ideal visibility in your app. In fact, if two colors are not above a certain contrast ratio, they would not pass what is known as the Wcag standards. Wcag stands for Web Content Accessibility Guidelines. These are universal guidelines that are set to make your content more accessible to people with disabilities, specifically colorblindness. Wcag, as well as Apple, recommends a minimum contrast ratio of 7 in order to ensure an optimal viewing experience in your app. This is set to make sure that your foreground content stands out enough from your background content to make sure that everyone can see what you're trying to display in your app. Now, a strong contrast ratio between elements will make your app easier to perceive. Let's look at the formula for how we calculate this contrast ratio. You can see here, this is the contrast formula, and the only thing you need to plug in is the brightness component of the two colors you want to compare, where B1 is the greater value and B2 is the lesser value. Now, we're going to come back to this formula a little bit later on in code, but for now, let's move on to custom coloring and theming in your apps. Now, some apps will support what is known as a universal app theme. This is just a common set of color palettes that will be used prominently through your app to give it a certain look and feel. As a developer, you might provide this option to your users so that they feel like they have a sense of customization, and it will delight them to choose their viewing experience. Here are some examples from the Reddit app of the same page, just shown in the different themes supported. You can see that things like the background color, the button tints, and much more change between themes, yet the content remains the same. You might be more familiar with a common example of app theming with light and dark mode. Here in the Twitter app, you can see they do a great job of defining the colors in each mode. Now, it's important to choose accessible colors when you're choosing themes and designing what colors will be shown for each element in each theme. Imagine if Twitter forgot to change the text color they wanted displayed in night mode. You'd then have a dark text color on a dark background, and you couldn't even read the text of each tweet. Managing what color should show up for each element in each theme can be very difficult to maintain and scale. Fortunately, with the announcement of dark mode in iOS 13, Apple has made this pretty much very easy for us. In dark mode, the things like controls, buttons, background colors, and more change for the whole iOS ecosystem. Let's take a look at what you need to do to make dark mode work in your app in iOS 13. First, let's look at the existing color palette provided to us from Apple on the UIColor API. These are probably very familiar to you. They are colors that you can use. They're named based on their color name. And depending on if you're in light or dark mode, they're going to have the same value. It's going to be the same shade of red no matter your mode. Well, now with dark mode, Apple suggests that you change these to be dynamic system colors. They're very similar to what you just saw. They're named after the color they represent. But the only difference being that they automatically adapt at runtime to the current trait environment. So if you're in light mode, you might get a different shade of red than you get when you're in dark mode. Additionally, these also adapt to another mode called high contrast mode. This can be set in the accessibility settings of your iOS device. Here's an example of some of the colors. The top version is the shade that you'll get at runtime in light mode. And the bottom version is what you'll get in dark mode. Now, it's important to note that the exact value of these colors might fluctuate between iOS releases, but Apple guarantees that they will be compatible in both of their respective modes. In addition to dynamic system colors, you're also going to want to adopt dynamic semantic colors. Very similar to what you just saw, these colors are named based on their usage instead of the color that they represent. The top version is what you're going to see in light mode, and the bottom version is what you're going to see in dark mode. Now, the first one, for example, is called label. This is meant for primary content shown for text in your app. So if you're in light mode with a white background, the text will render as black. Similarly, in dark mode, if you have a black background, the text is going to render as white. Now, these colors provided to us by Apple are limited, of course. So Apple provides us developers with the option to create custom dynamic colors. You can do this pretty easily in the asset catalog. Just create a new custom color set, and then you'll be provided with 3 options where you can set different values of colors. Light appearance is where you'll set the value of the color you want showed in light mode. Dark appearance is what you'll set for dark mode. And the third option, any appearance, is the color that will be shown in versions of your app that don't yet support dark mode. So iOS 12 and earlier. You can also do this with custom imagery. I haven't shown it on the slides, but it's very similar. You'll just make a new image set and set the image you want shown in each appearance. Now, if you want to define these custom colors programmatically, you can do that too. Here's some code that will show you an example of exactly how to do this. You first need to determine which mode your app is in, light or dark. You can do this by accessing it on the UI trait collection in a new enum called UI User Interface Style. You can access this on the trait collection, as I mentioned, which is provided on every view. Then, once you know which interface you're in, just return out the color for the custom dynamic color you want to set. Now, there might be instances where you need to access the actual value of your dynamic system color that will be rendered at runtime. You might need to do this when you're setting a CA layer, since CG colors aren't the same as UI colors. With this code, you can use the method called resolved color width, and that will then give you the actual value that will be returned at runtime, and then you can just convert it to a CG color as usual. Now that you know how to adopt dark mode in iOS 13, let's look at a different form of color customization you might provide in your app, letting users choose the actual colors. Now, with color customization, these colors are usually selected by the users. Since this is different for every person using your app, these colors likely aren't going to be stored on the client. They're going to be provided to you by the backend. These are probably going to be unique to one user or one area of your app. Think a user profile on Twitter, for example, the banner image or the banner background color per user. Here's a great example from the Slack app, where users can choose a custom color set for their left navigation menu. Similarly, in the Messenger app, each chat room can have a unique color and a unique icon. Now, that's pretty awesome, provides users with a sense of customization and delight. However, if you're the designer working on that team, you might start feeling pretty anxious. How are we going to make sure these colors are accessible? How are we going to make sure they look good? Well, this brings us to our final topic of the presentation: color collisions and how to handle them client-side. Now, as I mentioned earlier, these colors are probably provided by the back end. You can't make use of Apple's dynamic color system, since that all has to be set up before runtime. You also might run into contrast issues with dark mode with the user's color selection. Well, here's a few solutions I've come up with that hopefully you can use. The first one might be only let the user select their custom coloring from a predefined palette. This is great. You can pretty much ensure that the colors that are available to users are going to be accessible in both modes, and you know that they're going to be agreeable with your designers. Well, what if you want to give your users more free range? You want to let them choose from, say, an RGB color picker or an Hsv color picker. Now, something you can do is you can adjust the color they've chosen client-side to ensure visibility and contrast is at the minimum set by Apple. Here's an example. Let's say you're letting users customize a text color. If they choose yellow on a white background, that's pretty terrible. No one can read that. That's at the minimum contrast ratio two colors can have. Similarly, on the right, with this dark green on a black background, it has a contrast ratio of 6, but that's still really hard to read. Here's another example of non-text in the Reddit app. Moderators can choose a color to set on the background banner, the button tints, and more. If they selected purple, that looks pretty great. But what if they went rogue and selected white? Now the buttons have disappeared. You can barely read anything. Well, here's what I did to solve this problem. We're going to start by extending UIColor. Let's set our static variable for the minimum contrast ratio. I'm going to set it to 7 because that's what Apple recommends. Next, we're going to write a method to calculate the brightness of a given color. You can use the provided method by Apple, getHueSaturationBrightnessAlpha, where you pass in by reference the values that you want to get out. If this method is successful, we'll then just return out the brightness component, since that's all we care about here. Next, we have a method to calculate the contrast ratio. Remember that formula from earlier? Well, we're just going to plug it in here to calculate the contrast of the two colors passed in. Let's see that code in action. On the left, we have white and black with a high contrast ratio of 21. That's the maximum contrast ratio two colors can have. In the middle, we have this purple and black that has a contrast ratio of 11. That's pretty good. It's above a 7. And finally, from the example earlier, we have the yellow and white with the lowest contrast ratio two colors can have at 1. Here are some similar examples with text on a background. You can see the contrast ratios. Other than the first one in the top left, they're all pretty hard to read. Let's see what we can do to change that. Here, we write a method that will calculate the new brightness needed for your foreground color in order to meet that minimum contrast ratio. Now, we're going to use this method in our next method, where we're going to change the receiver's brightness component to match the passed-in value. So the value we calculated in the last method, we know that's the new brightness we need to meet that 7 contrast ratio. We're going to pass that in as a parameter, and we're going to return out a new color with that adjusted brightness component. The other components, hue, saturation, and alpha, are just going to remain the same. And finally, this is our last method where we pull all the pieces together. This is the only method that you're going to need to use from the calling areas of your code. Basically, what this is going to do is adjust the receiver if needed to meet that minimum contrast ratio with the other color you pass in. If it's already at a 7 or above, that's fine. Just return the same color you've passed in. If not, let's adjust that to make that foreground color lighter or darker so that we know it's going to be accessible. Let's run the code. Here, we have that dark green on the black background with a contrast of 2.33. When we run this with our code, here's what we get. That's the minimum contrast ratio of 7. Much easier to read, huh? Let's try it in light mode. Here's that yellow on the white again. When we run this code, wow, that's a super dark color. Now, you probably can't even tell in the back that that's a shade of yellow. That looks pretty dark. Since this is the contrast ratio 7, that's great for text, but your app might have different needs. If it's not something so crucial like text on a white background, let's say it's a banner color, you and your designers can work through this and decide what contrast minimum is great for that area of the app. So for example, let's say we've reduced that to between a 2 and a 3. Here's what you get. You can still tell it's a yellow. You've maintained the user's selection while making your app accessible. If you want to play around with this code, feel free to download the playground at this link. The slides will also be made available in the slides channel on Slack after the talk. So to recap what we've learned today, we've talked about color spaces and the components that make up a color. We've learned that contrast ratio is the difference in 2 colors, and the brightness really affects this. We've also learned about hue, saturation, and brightness. Additionally, we talked about color contrast and how it's really important for making your app accessible, especially for those with color blindness. Then we talked about how to adopt iOS 13's dark mode. We looked at different forms of color customization and theming set by users in your app. And finally, we walked through some code examples extending UIColor on how to handle these color collisions client-side. I hope you can take what you've learned today and provide a colorful viewing experience for the users in your app. Thank you.